Welcome back. So now we're going to learn two triangle theorems that are going to help us as we solve congruence problems and as we solve other kinds of problems as well. The first one is triangle sum theorem. By the way, this one is in your notes. So triangle sum theorem, the measure of the interior angles of a triangle sum to 180 degrees. So here in our diagram, the measure of angle A plus the measure of angle B plus the measure of angle C is 180 degrees. In your diagram, you can see I have marked where an interior angle is, that it's inside the triangle. We do have angles outside the triangle. We'll talk about those in a later podcast, but I would like you to just mark that that's the interior angle. So if you have a triangle, then you know the sum of its three interior angles must sum to 180 degrees. And this is something that you maybe already know, right? So this might be your little review. But you maybe don't know our next theorem, which is based on triangle sum theorem. And here comes our next theorem now. By the way, the next theorem, here it is in your notes as well. You don't have the pictures, but I am going to have you draw that. So while I'm reading over third angle theorem in your notes, you could also draw the pictures there. That you see, triangle QRS and triangle TUV. And actually, I also want you to write next to them the word given. All right, so let's take a look at third angle theorem. If two angles of a triangle are congruent to two angles of another triangle, then the third angles are congruent. All right, so copy those two triangles in your notes. Make sure, draw the best you can a triangle, two triangles, and then I want you to mark angle R here, right, and angle U, and show that they are congruent, and then mark with two hash marks angle S and angle V and show they're congruent as well. Right. Underneath your picture, and of course write given next to it, and underneath the picture I want you to write prove, and I want you to write angle Q is congruent to angle T, and underneath that I want you to put in parentheses triangle sum theorem, or excuse me, third angle theorem. So we are proving the third angle theorem. Whenever you are proving a theorem, you cannot use that theorem to prove itself. Right, so we're proving third angle theorem with our generic triangle here. Generic means there's just really nothing special about this triangle. It just happens to be two triangles with some given information. And if we can prove it is true in this case, this general case, we can prove that it is true in all cases. Right, so let's think for a proof. Where do we always start on our proof? We always start with the information we're given. And you might think, I only see a picture. What am I supposed to write? What do we have pictured there? I think we have pictured triangle QRS and triangle TUV. And that's important information. I'll tell you why in a few moments. And the reason we know that we have two triangles here is it's given. We were given these two triangles. Well, so now we have two triangles. Big deal, right? Big whoopee-doo. What are we going to do with that? Well, I think on the last page we just learned something about two triangles, right? Or about a triangle in general. And that's why I really needed to state that I have a triangle here, because now that I've said that QRS and TUV are triangles, I can also state that angle Q plus angle R plus angle S equals 180 degrees. And I can say that angle T plus angle U plus angle V equals 180 degrees. What happened to S? There we go. So angle Q plus angle R plus angle S equals 180 degrees. Angle T plus angle U plus angle V equals 180 degrees. And you might think, well, why is it important to say that? Well, if I'm trying to prove something congruent, something equal, right, it would help if I had an equal statement, an equality. It's kind of hard to prove two things are equal without an equality statement. All right, so how do we know that angle Q plus angle R plus angle S equals 180 degrees and angle T plus angle U plus angle V equals 180 degrees? Why, of course, that's the triangle sum theorem that we just learned on the last page. And you might be thinking, well, what are we going to do with that? Well, the fact that we have two triangles was not the only thing that we were given. We were also given, which is why I had you mark it on your diagram, that angle R. Actually, I want to say something else, but actually before I say that, sorry about that. I almost forgot. I want to say one other thing first. Well, even though I could switch my statements around, I want to say this statement first, because I think maybe you'll catch it easier if I say this statement first before I say the next statement. What do you notice about angle Q plus angle R plus angle S and angle T plus angle U plus angle V? Do you notice that angle Q plus angle R plus angle S and angle T plus angle U plus angle V are equal to the very same things? Well, if they're equal to the very same thing, that must mean that angle Q plus angle R plus angle S is equal to angle T plus angle U plus angle V. Well, how do we know those things are equal? What tells us that if two things are equal to the same thing, they must be equal to one another? Well, that's the transitive property. So you see how we go from what we're given. We use things we know to be true all of the time, definitions from what we're given, to make a statement. Now we've got all the angles in the same statement, and that's what we want, right? Because eventually we've got to get just Q and T in here. But we've got lots of other angles, R's and S's and U's and V's. Can we say anything about those angles? Well, if you remember, now I'm going to say my statement. I had you mark on the diagram that angle R was congruent to angle U, and angle angle S was congruent to angle V. We marked it on the diagram. That was part of the given information, so that is given. So make sure, by the way, you are putting this proof in your notes. Right? You need to know how to prove triangle sum theorem, or third angle theorem. All right, so now let's look at what else I can say. All right, well, you know, when I write U's and V's, don't they look a whole lot alike? I don't think I like U's and V's. I'm going to say this instead. Angle Q plus angle R plus angle S is, it's supposed to be congruent there. Oh, no, excuse me, that's supposed to be equals. Sorry, I was looking at the step below. All right, so I'm going to say angle Q plus angle R plus angle S is equal to angle T plus angle R plus angle S. I don't like the U and V. I'm going to put R and S in there instead. Well, how can I just do that? Just be replacing angles willy-nilly like this. Well, notice that angle R is congruent to angle U. So I decided to replace U with R. And angle S is congruent to angle V, so I decided to replace angle V with angle S. What property, what theorem, what allows us to just replace things that are equal with something else? Right? If you're cooking and you don't have one of the ingredients, so you replace it with another ingredient so you can still make the recipe. What are you doing? You're making a substitution. So this is the substitution property. Well, if I look at this, my statement here at step 5, I've got R's and S's on the left-hand side. I got R's and S's on the right-hand side. Maybe I don't need all these R's and S's. Maybe I just need angle Q is equal to angle T. Well, how can I just drop these R's and S's? Well, think what you do when you have an equation like 3x minus 1 is equal to 7. Or let's see, plus 1 is equal to 7. And then you go from that to 3x is equal to 6. What'd you do to both sides so that you could combine like terms? You subtracted the same thing from both sides. If we could subtract numbers, can't we subtract angles? Of course we can. You can subtract anything you want. Right? So we just subtracted angle R and angle S from both sides. We used the subtraction property. And actually, we've almost proven that angle Q is congruent to angle T. It's just a minor thing, but we really do want it to match exactly. And equals isn't quite congruent. But we can go from equals to congruent. What property allows us to change an equal sign to a congruent? It's that, oops, I did not mean to go, I think you can still see it okay. I did not mean to extend the page that many times. All right, so what allows us to change equal to congruent? Well, let's think. Things that are congruent have the same measure. That's the definition of congruence in terms of the congruent symbol. Right, so definition of congruence. Right, so when we're using that symbol, what does that symbol mean? Right, it means that you have, if you have the same measure, that you have to be congruent. And now we have actually proven the third angle theorem. And so this should be in your notes as well. And now you can see it has to be true all of the time. That if two angles of a triangle are congruent to two angles of another triangle, the third angles must be congruent as well, right? Because the same amount is going to be left for those third angles, right? Because of triangle sum theorem. So this is really based on triangle sum theorem. And if you have any questions on this proof, let me know. But I really want to help you improve your ability to prove things to be true. All right, let's continue, and let's use this third angle theorem that we have now proven to be true. And the first, I think I have like 2 problems that are not in your notes, and then I think I have 2 problems that are in your notes, and then one more. All right, so if 2 angles of one triangle are congruent to 2 angles of another triangle, the third angles are also congruent. All right, so we could find angle B here using triangle sum theorem. All right, so we know the angles in a triangle add to 180. So 65 plus 75 plus angle B equals 180. 65 plus 75, that's going to give us 140. And if we subtract 140 from both sides, that means angle B is 40 degrees. All right, so notice that this angle is congruent to this angle. And this angle, isn't that lovely, is congruent to this angle. So we have 2 angles of one triangle are congruent to 2 angles of another triangle. Therefore, we can use third angle theorem. Since angle C is congruent to angle Z, they have the same measure, and angle A is congruent to angle Y, using third angle theorem. So here I'm just a label on the top. I don't want to use that as part of my sentence, then that order. All right, here's my explanation. So since angle C is congruent to angle Z and angle A is congruent to angle Y, using third angle theorem, angle B is congruent to angle X, and angle X equals 40 degrees too. There we go. So we've used the 2 theorems that we've learned to find the measure of 2 angles in our triangle, in our triangles. All right, let's do another problem. And here we go. There we go. Third angle theorem. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are also congruent, and of course we've also learned triangle sum theorem. The sum of the measures of the interior angles of a triangle add to 180 degrees. We want to find the value of x and y if the triangles are congruent. And I'm sorry, I erased this, and I also erased x and y, but they went there. All right, let's find x first. Right, and so to find x, we're going to use triangle sum theorem. Right, so we know these angles add to 180 degrees. So therefore, 45 plus 20 plus x is 180 degrees. That would be 45 plus 20 is 65. If we subtract 65 from both sides, x is 115 degrees. Right, so now if you look at our diagram here, we can see that these two angles are congruent. And now we know that these two angles are also congruent. So that means that we can use third angle theorem. Right, so using third angle theorem, we want to find the measure of y. Right, so since two angles of the triangle are congruent to two angles of the other triangle respectively. And the reason I'm using the word respectively isn't necessarily that the triangles have a lot of respect for one another, but rather we want to make sure we're stating that the corresponding angles go together respectively. So if two angles of the triangle are congruent to two angles of the other triangle respectively, using third angle theory. Well, what the heck? That was not very respectful. Let's try that again. Using third angle theorem, y has to equal 20 degrees. Right, since two angles are congruent, using third angle theorem, the third angles have to be congruent as well. Y is going to be 20 degrees. All right, next one is in your notes. We're going to be using triangle sum theorem, and then depending on the order we find the angles in, we are going to be using some other properties as well. Oh, I'm sorry, I'm thinking of the next problem. This one, we're going to be finding the missing angles using third angle theorem. On the next one, we're going to be using triangle sum theorem. All right, so this one's in your notes. We want to find the value of x in the diagram. And notice I added letters to mine, so we would have a way to name the angles. You'll need to add letters as well. So this is triangle DOG and triangle PIG. So let's find some angles that have to be congruent. Do you see any angles that have to be congruent? So for instance, I know that angle I, actually I'll start with angle O. Angle O has to be congruent to angle I. Notice they both have that box in them, and that means that they're right angles. And we know that all right angles are congruent. Because they all add, or not add to, they all equal 90 degrees. So all right angles are congruent. All right angles equal 90 degrees. Right? Either reasoning would be correct. All right, so now we know one pair of angles is congruent. Do we have another pair of angles? Well, hopefully you see it. This time I am going to have to use 3 letters to name the angle because there's actually 4 angles in the same location. But I, for instance, know that this angle is congruent to this angle. that angle OGD is congruent to angle IGP. And how do we know those angles are congruent? Well, look at their position. Those are vertical angles. Right? So they are vertical angles. And vertical angles are always congruent. All right, so now we've got two pairs of angles that are congruent. What must x be? Well, if two angles are congruent, the third angles will have to be congruent as well. So x is going to have to be 20 degrees because using third angle theorem, angle D is congruent to angle P. Right? So we've already shown, you can't just use third angle theorem all by its lonesome. But if you've already shown that two pairs of angles are congruent, then you can use third angle theorem to show the third pair of angles has to be congruent as well. All right, and now we have solved this one. Let's do the next one, and we'll use triangle sum theorem. So the other reasons that we're going to use, other than triangle sum theorem, kind of depends on the order that we go in. Right? I'm going to try to go in order from 1 to 7, unless A, I can't go in order because I need something else to find that angle measure, or B, because I choose not to because I want to have you practice another way to find an angle measure. So I cannot start with angle 1 because I need more information, but I could start with angle 2. So for instance, I know that angle 2 is equal to 90 degrees. Did you know that angle 2 is equal to 90 degrees too? I hope so. Right? Because those two angles are vertical angles. So we're going to write the measure and just the theorem. We're not going to put in an explanation here. There's only so much room in the little box. We'll just put the theorem on this one. All right, so but now that I know angle 2, now I could find angle 1. Right? And we'll do a little solving, so that's kind of a justification on some of our answers. So angle 1, for instance, we know that 90 plus 45 plus angle 1, well, that's the three angles in the triangle. We know they have to add to 180. So 90 plus 45 is 135 degrees. And we subtract 135 from both sides. Angle 1 is equal to 45 degrees. So now we know the measure of angle 1 is 45 degrees. And that would be triangle sum theorem that we used. I'm going to abbreviate. There we go. I'm going to abbreviate there. All right, so now let's find, I'll put the 45 here, even though I don't really need to. Now let's find angle 3. I can find angle 3. Right, so notice I know two angles in the triangle, right? 90 degrees and 30 degrees, and those two plus angle 3 have got to add up to 180. 90 plus 30 is 120. Subtract 120 from both sides, angle 3 is 60 degrees. So now we've got angle 3, and again we use triangle sum theorem. Well, if we know angle 3, we know angle 4, right? That's got to be 60 degrees as well, right? Because those are vertical angles. I'm going to abbreviate angles there. All right, so now let's go over to angle 5. Actually, I'm going to go in order except for the angle 1 and angle 2. I happen to know the measure of angle 5. I actually could find it two different ways. Right? I could add up 60 plus 143 plus angle 5 and get 180. Or I can notice that angle 5 and that 103 degree angle, those are two adjacent angles. Right? Together they form a line. So that means that angle 5 plus 103 is equal to 180 degrees. And actually, I'm going to solve that down here because I have more space. We'll write the answer up there. So angle 5, oh, I hate when it does that. Angle 5 plus 103 equals 180. If we subtract 103 from both sides, angle 5 is equal to 77 degrees. So we knew that angle 5 is equal to 77 degrees, and we used linear pair angles. I'm going to write 77 just a little bit neater. Oops, there goes my equals too. And part of 5. It's not any neater, is it? Oh well. All right, so now let's find angle 6. Well, we can find it actually two ways. I think I'll use this. I could either, we'll say both ways. I could either notice that angle 6 and 103 are a linear pair. So what must angle 6 be? Or I can notice that these are vertical angles. Right? Either way, angle 6 is 77 degrees as well. And I'll say vertical angles because I didn't solve it out. Last one, angle 7. All right, so we've got two angles in the triangle. 70 degrees, 77 plus 60. If we add in angle 7, they're going to add to 180 degrees. So 77 plus 60 is 137. And we subtract 137 from both sides. Angle 7 is 43 degrees. And now we have found all of the angles. And this time we used triangle sum theorem. All right, so if you need more time to write these in your notes, go ahead and pause the tape. Yeah. Otherwise, come join me on the last problem on the podcast. And this one that's coming up is not in your notes, but we'll do some other similar ones that will be in your notes. Oops, and when I was erasing, I erased part of my word. And certainly, this is a really good problem. It does have a lot of information in here. And feel free to copy that in your notes on maybe a sticky note or an extra sheet of paper. I notice those kinds of things. All right, so we want to complete the congruent statement that triangle XYZ is congruent to and Y. But we want to also look at some more information about this. This has got a lot of information. So, for instance, we're told that WZ is congruent to XY. Actually, I should say WZ is congruent to, I'll write it over here. WZ is congruent to YX. I should match them up exactly. And we're also told that WX is congruent to Z, WXYZ. So WX is congruent to YZ. My congruent symbol looks really weird. You got a little glitch in the board there. Maybe I should do this and just move it over. But there's some other things that we know to be true, even though it's not written. It's not, and we weren't, given symbols. Nobody said anything. But just from the information we're given, we know other things to be true as well. Let me write in YZ. We also know that WZ has to be parallel to YX. Right? So it has nothing to do with the fact that they're congruent. Right? That's not why we know they're parallel. Notice that XZ is a transversal. Right? It's a line segment that intersects, or two lines intersects WZ, and it intersects XY, or excuse me, WZ and XY, yeah, YX. Right? So it intersects those two lines. And we can see that we have some angles that are congruent. We see that we have, it's already marked that angle ZXY. So ZXY is the blue angle here, those two. That angle is congruent to angle XZ, right here, and then go over to W, XZW. So those two angles are congruent. And we also know that angle, because it's marked, right, angle WXZ, wait, I have W, do I have W, the wrong angle's marked? WZ, I have that one twice. Oh, I'm sorry, I'm looking at the wrong one. My eyes didn't move down. Oh, is that, okay, I marked the second angles first. That's okay. Angle ZYX, we'll do that 1 second. So angle, or ZYXY. So angle ZXY. I swear I have the same one marked twice. Here, you know what? We'll just write them again. I think going back and forth looking, I'm getting myself dizzy. All right, I'll just write it again. So the ones I marked was angle WZX. That one is congruent to angle YXZ. Right, those are the two blue angles. And then likewise, angle, I'm going to start with Y. YZX is congruent to angle, so Y goes with W, WXZ. It's easier for me to write it as I say them. All right, so what's special about those angles? Notice that they're on opposite sides of that transversal. So if your angles on opposite sides of the transversal are congruent to one another, right, we know our lines are parallel because those are alternate interior angles. So alternate interior angles are formed by parallel lines, right, are going to be congruent. Right, so that the only way those angles could be congruent are as if these lines are parallel. So that wasn't given to us, but we know it has to be true. What else has to be true? So let's figure out, since these are congruent, let's figure out the congruent statement. Let's figure out what type of transformation maps one triangle to the other. And then let's talk about what else could be marked congruent. All right, so we're going to complete the congruence statement on triangle XYZ. Right, so XYZ, that's the triangle, let's label them. So that triangle XYZ is this triangle here, and then the other triangle is triangle 2. All right, so X goes with Z on the other triangle, right? X over here goes with Z over here. All right, so that way I can already eliminate. I don't know what happened to my letters here. We got A, B, C, and D. We can already eliminate A and C. All right, let's continue. All right, so then Y goes with W, right? It's the angles that aren't marked. Y goes with W. And then Z is going to go with X. So B is the correct answer. That one is correctly matched. Right? So that's something that you'll have to be able to do is match up the corresponding parts of congruent triangles. What type of transformation maps one triangle to the other? Right? Could it be a reflection? If you say, I don't know, I don't think so, then you'd be correct. Right? So we have to make sure we match up the corresponding parts, right? If I just reflect, right, does this angle here, what I just put a green mark on, does that go with that angle? Are they the same? No, they're not congruent. I got to get this angle over here, right? And then I got to get this angle over here. Well, how am I going to get that angle over? Well, that's got to be a rotation. All right, so what type of transformation maps one triangle to the other? A rotation. Now we don't know what point, right? But it's going to be inside the it's going to be between the two triangles, right? Somewhere inside the W, X, Y, Z. So a rotation about a point in our whole polygon here, W, X, Y, Z. That would map triangle XYZ to triangle ZWX. Right, so we can't be as specific as we'd like when we're not on a coordinate plane, but we can still do our best. What else can be marked congruent? Let's see if you knew the other two things. There are two things. Think in your head what else can be marked congruent. And then I'll also put Y. Y could be marked congruent. I hope you said angle W is congruent to angle Y. All right, how do we know? That is third angle theorem. If two angles of a triangle, let's put if two triangles are congruent. We're going to try and abbreviate. So if two angles of two triangles are congruent, the third angles are congruent as well. The third angles are congruent. One other thing can be marked congruent. It's going to come into play a lot in our next lessons on triangle congruence. And I bet you didn't think of it. I can mark XZ congruent to ZX. Why can I mark those two sides congruent? Now we finally got to something where you can use the reflexive property. Reflexive property. They're the same segment. So line segments are equal to themselves. And there we go. This one wasn't in your notes, but we got a lot of information on it. And that's going to finish my podcast. All right, so in the next podcast, we're going to be looking specifically at triangle congruence. Thanks for watching. Bye for now.